Hey everyone, and welcome. Have you ever written some Python code that, it works, but you just have that feeling in the back of your head that there has to be a better, cleaner way to do it? Well, you are in exactly the right place. Today, we're going to go beyond just getting stuff to run. We're going to dive into how to write truly Pythonic code. So let's jump in and level up your skills. So, I want you to think about your own projects for a second. Is your code sometimes a little tangled? Do you find yourself writing these manual counters or really complicated loops for tasks that feel like they should be super simple? Yeah, I think we've all been there. The good news is Python has some absolutely brilliant built-in tools to handle these exact situations. We often start with code that looks like the stuff on the left. It gets the job done, sure, but it's clunky, right? We're manually keeping track of an index variable. The goal is to write code that looks like what you see on the right. It's clean, it's readable, it's direct. That is the Pythonic way. And I promise, by the end of this, writing code like that is going to feel like second nature. All right, our first tool is one of my absolute favorites, the filter function. The best way to think about it is like a sieve, seriously. You just pour all your data through it, and it only lets the items you actually want pass through, catching everything else. It's so powerful for cleaning up data. So, how does this thing actually work? It's really simple. The filter function takes two things. First, a function that's going to return either true or false, and second, the list or sequence you want to go through. It then applies that function to every single item and gives you back something called an iterator, which is just a super efficient way to get the items one by one that only has the items that made the function say true. Let's look at a really quick example. We've got a function here called isEven that, checks if a number is even. We pass this function and our list of numbers into filter. And what's the result? An iterator that contains only the even numbers, 2, 4, and 6. It's simple, it's effective, and it's so much more readable. Okay, time for a little challenge for you. You've got this messy list here with all sorts of data in it. How would you get rid of all the falsy values? Things like 0, empty strings, the Boolean false, and none, in just a single line of code using filter. Go on, take a second to think about it. And here's the solution. Isn't that beautiful? So concise. List of filter, none, messy data. The little bit of magic here is passing none as the function. When you do that, filter doesn't use a custom function. It just uses Python's built-in idea of what's true. So it automatically weeds out everything that's falsy, leaving you with just the good stuff. All right, let's move on to our next tool. Have you ever needed to loop through a list and also know the index or the position of each item? I bet you have. There's a clunky way to do it, and then there's the professional way. Let's talk about the smart counter, enumerate. The difference here is just night and day. The old way, using ranged len of items, forces you to do this extra step of looking up the item with items I. But the Pythonic way, it uses enumerate to just hand you both the index and the value in one clean, readable step. It directly says what you want. For each item, I need its position and its content. So what really makes this so much better? It really comes down to three things. First, clarity. It just makes your code way easier for anyone to read. Second, it's less code, which always means fewer chances for typos and bugs. And third, robustness. It's just safer and more direct than manually grabbing an item by its index. Okay, another hands-on moment for you. You've got this list of numbers. How would you use enumerate to find all the numbers where the value is exactly the same as its index in the list? This is a perfect problem for our new tool. And there's the solution. Look how simple that is. We just loop through with enumerate to get both the index and the value for each item. Then, a simple if index equals value check does all the heavy lifting. No messy index tracking, just clean, logical code. Okay, let's move on to our third and final tool for today, zip. If filter is the sieve, then zip is the ultimate matchmaker. Its whole job is to take two or more lists and pair up their items, like matching names to scores or products to prices. The zip function takes as many lists as you want to give it and creates an iterator that spits out these little tuples. Each tuple has the first items from all the lists, then the second items, and so on. But, and this is the critical detail you have to remember, it stops as soon as the shortest list runs out of items. In this classic example, we've got a list of names and a list of scores. When we zip them together, we get these perfect little pairs. Alice with 85, Bob with 90, and Charlie with 88. It just perfectly matches up the elements that are in the same position. Time for your next challenge, and this is a really common task in Python. You've got a list of keys and a list of values that correspond to them. How can you combine them into a dictionary in a single, beautiful line of code? The answer shows the true power of combining Python's built-in functions. Dict, of zip, of keys, values. That's it. The zip function creates all the key value pairs for you, and then the dict constructor takes those pairs and builds a dictionary right from them. It's honestly one of the most satisfying one-liners in all of Python. Now, this brings up a question I see all the time. If you zip a short list with a long list, the result is only as long as the short one. Why doesn't it throw an error or fill in the blanks or something? It's a great question, and the answer really gets to the heart of Python's design philosophy. The key thing to understand is that this is a feature, not a bug. It's designed this way for predictability and for safety. By stopping at the shortest list, zip guarantees that every single pair it gives you is complete, which prevents nasty index error bugs in your code. Now, if you do need to keep all the items and pad the missing ones, there's a tool for that too. It's called iterables.ziplongest. So far, we've looked at these tools one by one, but the real magic, the really cool stuff, happens when you start combining them. This is where you can solve surprisingly complex problems with just a line or two of really expressive code. Look at this combination. It's amazing. First, zip takes the names, marks, and grades and groups them into these nice little records. Then we feed that entire result into enumerate to add a line number to each record, and we tell it to start counting from 1. This single line structures and numbers our data perfectly. This is the goal of Pythonic code. You chain simple, readable tools together to do complex jobs without complex logic. So let's wrap this all up. You've just added 3 incredibly powerful tools to your Pythonic toolkit. And these aren't just fancy tricks, okay? They are the standard, the preferred way of writing clean, readable, and robust Python code. So let's lock this in. Next time you find yourself writing a loop with a messy if statement inside, I want you to think filter. The next time you create a manual counter variable like I = 0, stop and use enumerate. And before you ever try to access 2 lists by the same index number, reach for zip. The next time you write a loop, I want you to ask yourself one question. Am I describing what I want, or am I describing how to get it step by step? Always strive for the what, and you'll be well on your way to writing truly elegant Pythonic code. Happy coding!